Hi, and welcome to section 3.5. This is actually the last section in the unit on expressions and equations. So yesterday we did a little bit in playing around with how to solve a two-step equation. Today we're going to talk about how to formally do this. So it says solve negative 3x plus 5 is equal to 2. So let's rewrite it so that I have some room. So negative 3x plus 5 is equal to 2. When you have an equation that has a coefficient and a variable, and then some addition and subtraction, you always start with undoing the addition or subtraction. It's slightly opposite from PEMDAS. In PEMDAS, you would start with the multiplication. In this case, you're going to start with the addition or subtraction so that you can get this alone by itself. So we actually, since we are adding a 5, we're going to subtract a 5 from both sides. So we end up with negative 3x, and 5 subtract 5 is 0. So we have negative 3x is equal to 2 subtract 5 is negative 3. And now this is beginning to look like what we're used to, that we did in our last section, where you are solving a single-step equation with division or multiplication. So since this is negative 3x, 3 times x, you're going to divide, because that's the opposite operation. So you're going to divide negative 3x by negative 3. So if you do it to one side, you have to do it to the other side. And negative 3 divided by negative 3 is 1, so you'll be left with 1x, which we write as x, is equal to negative 3 divided by negative 3, which is 1. So let's check to see if that works. So negative 3 times 1, add 5, is equal to 2. Is that true? Well, negative 3 times 1 is negative 3. Add 5 is equal to 2. Negative 3 plus 5 is equal to 2, and 2 is indeed equal to 2. So it's correct. All right. Why don't you pause me and see if you can solve these three equations. Remember, you're going to undo the addition or the subtraction first. In this one, remember that you need to apply the distributive property before you actually start to solve this equation. So pause me and then start me back up again when you try them out yourself. Okay, hi, welcome back. So let's rewrite this. 2x plus 12 is equal to 4. So we're going to undo, we're going to undo the addition. So 2x, 12 minus 12 is equal to 0. So 2x is equal to 4 subtract 12, that should give us negative 8. Divide by 2, because that's the opposite of 2x, is we're going to divide. These will cancel out. If you divide by 2 on one side, you have to divide by 2 on the other side. So you end up with x is equal to negative 4. And does that work if I put that back into the equation? So 2 times negative 4 plus 12, plus 12, yikes, let's erase all of that, plus 12, is that equal to 4? Well, 2 times negative 4 is negative 8. Negative 8 plus 12, we're asking if this is real, if this is true. Is that equal to 4? Well, negative 8 plus 12 is 4, and 4 is equal to 4. So that is correct. All right, let's try this one. Negative 5c plus 9 is equal to negative 16. So since we're adding 9 here, we're going to subtract 9 first. Subtract 9 from both sides. We end up with 5c. Negative 16 subtract another 9 is equal to negative 25. So 5c is 5 times c, so the opposite is division. And these cancel out and become 1. So c is equal to negative 5. Well, does that work? So negative 5 times another negative 5 plus 9, is that equal to negative 16? Well, negative 5 times negative 5 is 25. plus 9, is that equal to 16? Negative 16. It's not, actually, because this ends up being 34. Is that equal to negative 16? So clearly I did something wrong here. So let's go back and look to see what I did. Well, negative 5c plus 9 is equal to negative 16. I subtracted 9 from both sides. That makes sense because these will cancel out and be 0. Remember when I said leave no sign behind? I did. I forgot a sign. So this should be negative 5c, which makes that negative, which makes that negative, which makes this a positive 5. So when we substitute, it's actually negative 5 times a positive 5, which would give us negative 25. So is negative 25 plus 9 negative 16? And it is. That's where I went wrong. So see, there's actually, you should always get these correct because you need to go try to see whether or not it works when you substitute it back in again. You actually can't technically get the wrong answer if you go back and check. Okay, so let's try this one. First thing we're going to do is distribute that 3. So we end up with 3x subtract a 12 because it's 3 times a negative 4 is equal to 9. Okay, well, I'm going to add 12 to both sides because I was subtracting 12. I end up with 3x is equal to 21. Now if I divide both sides by 3, I end up with x is equal to 7. Let's go substitute that into the original and see if it works. So 3 times 7 subtract 4 is equal to 9. 3 times, doing PEMDAS, we know that we do the parentheses first. 7 minus 4 is 3. So we're asking if this is true. Is that equal to 9? And yeah, 3 times 3 is 9. So those are equal, and that works. Okay, let's go on to the next one. So now we're going to get into some fractions here and dividing our variables. So x divided by 8, subtract subtract 1/2 is equal to negative 7/2. Well, if I subtracted 1/2, I'm going to add 1/2. So add 1/2. X over 8 is equal to negative 7/2 plus 1/2 is negative 6/2. Now, since this is x divided by 8, we are going to multiply both sides by 8. So 8 divided by 8 is 1, so we end up with x is equal to, we're going to cross simplify because remember I am lazy and don't like to multiply big numbers. So negative 6 times 4 is actually negative 24. All right, well, let's see if this works in our problem. So negative 24 over 8, or divided by 8, subtract 1/2 is equal to negative 7/2. All right, so let's actually simplify this. We're not gonna, well, we can either simplify this, but I don't think we can simplify it. Let's see, how can we simplify this? This can be, let's see here. Can we divide both sides, the top and the bottom, by 4? I believe we can. We can get 6/2, right? Because 6 times 4 is 24, so we have negative 6/2. Subtract 1/2. Is that equal to 7/2? And if I have 6 and I subtract another, if I add its opposite and I add another negative 1, I end up with, oops, remember, keep our signs here. Negative 6 plus negative 1 is negative 7/2, so this is true. Negative 7/2 is equal to negative 7/2. All right. Why don't you, let's see, why don't we try these on your own? So pause me, and then I will show you the answers. So hi, welcome back. So let's see here. M divided by 2 plus 6 is equal to 10. So the first thing we're going to do is subtract 6 from both sides. Get rid of the 6. Remember, you always do the addition or subtraction first. So we end up with m divided by 2 is equal to 4. If this is m divided by 2, I'm going to multiply both sides by 2. I end up, these cancel out, I end up with m is equal to 8. Well, does that make sense? 8 divided by 2 plus 6, is that equal to 10? Well, 8 divided by 2 is 4. 4 plus 6, is that equal to 10? And it is. 10 is equal to 10. All right, negative z thirds plus 5 is equal to 9. So negative z thirds plus 5 is equal to 9. I'm going to subtract 5 from both sides. I end up with negative z thirds is equal to 4. So since this is negative z divided by 3, I'm going to multiply it by 3 because that's the opposite. So these cancel out, so I end up with negative, oops, interesting. I end up with negative z is equal to 12. Now remember the other day we had negative a is equal to, I think, negative 24. And in order to make that negative sign, because we just want z is equal to something, in order to make that negative sign go away, we're going to multiply negative 1 on both sides. So we end up with negative 1 times negative z is z. We end up with z is equal to negative 12. Well, let's substitute that back in again. Negative 12 over 3 divided by 3 plus 5, is that equal to 9? Well, negative times negative is a positive. 12 divided by 3 is 4. So is 4 plus 5 equal to 9? And it is. So that works. All right, let's go up and try this one. So 2/5 plus 4a, is that equal to, or is equal to negative 5/6? So we're going to subtract negative 2, or subtract 2/5 from both sides. So we end up with 4a. Negative 6 plus another negative 2 is negative 8/5. And we're going to divide this side by 4. And we're going to divide this side by 4. Divide by 4. Now if you remember, keep it, change it, and flip it. We're actually multiplying by the reciprocal. So a is equal to negative 8/5 times 1/4. I'm going to cross simplify. That's 1. That's 2. So a is equal to negative 2/5. So let's see if that works. So, and I'm going to do it down here because I think my face is over there somewhere. So we're going to try it down here. So 2/5 plus 4 times negative 2/5, is that equal to negative 6/5? So let's do this. Negative 4, so it's actually negative, 4 over 1 times negative 2/5. So 2/5 plus a negative 8/5, is that equal to negative 6/5? And 2 plus a negative 8 is negative 6. So yes, that is correct and it works. All right, let's see what else we have. Okay, so this one is saying we need to simplify this before we can actually solve it. So we're going to solve 3y, subtract 8y is equal to 25. Well, if we combine these like terms, we end up with negative 5y is equal to 25. And if we divide both sides by negative 5, y is equal to negative 5, because that's actually part of the equal signs. So 3, let's check it, 3 times negative 5, subtract 8 times negative 5, is that equal to 25? So is negative 15 subtract a negative 40, is that equal to 25? So let's simplify this a bit. Negative 15 plus 40, is that equal to 25? No, 40. Subtract 15. That's 3. Borrowing 5. 1 subtract 25. So yes, that works. All right, I think you have enough that you can start and try these on your own.